Hi everyone. So we're going to be continuing our lessons on mirrors, and we're going to be going into a little bit more depth than we did last week. Last week you should have explored exactly what real images are, virtual images are, and exactly how you end up seeing those in a concave or a convex mirror, or even a plane mirror. So we're going to keep going on. You're going to see examples of what this looks like, and you're actually going to see, whoopsie, you're actually going to see how we would be able to draw a specific reflection depending on what type of mirror we have. So, uh, basically when we're starting out, we're thinking about mirrors, like the kind you would have in your house, right? Those are usually plane mirrors, and those are our best reference for what mirrors actually are, okay? And whatever we see back at us is, of course, not how others see you. That's why whenever you point to your right eye, people think that you are pointing to, like, they see your left, right? They see the mirror image of you. So, um, the first thing that we can do to see how this kind of phenomenon happens is by looking at what an image with words would look like. So, for example, it asks us to think about if we're wearing a shirt with the word science on it, draw what the image would look like in the mirror. So, I've never used this before, so let's go ahead and see how it works. Um, let's pretend like I have my mirror right here, right? And we're going this way, right? Wow. Okay. So, and I've got a shirt that looks something like this. And then I'm also going to have a shirt on this side that doesn't look like it at all, but we're going to try. We're all just doing the best we can. So, um, let's say I have the word science written on it. This is hilarious. Okay, so the image you're going to see on the other side is not just going to be science again. I'm not going to be able to write it left to right like I would. It would be a reflected image. So it's going to be backwards, and this is going to be absolutely miserable. But I'm doing my best. Okay, you get my point, right? Yeah, it is a backwards image. One that goes off the t-shirt too. All right, I'm gonna leave it at that. But here on this side, we of course have our object, which is what it started off as. This is not. And over here is our image. I don't think it wants to leave the eye on there. There we go. Okay. You get the point. Anyway, historical context for this kind of thing is Da Vinci actually was ambidextrous. What he could do, and what he did when he wanted to kind of disguise his notes, was that he would take he would write with his left hand, and he would write backwards, so that whenever he saw the reflected image of the notes, it looked correct, but other people would have a really hard time seeing this. So whenever we want to actually figure out where the image would be on the other side of a mirror, what we can do is analyze the image using what we already know about light rays. So laws of reflection help us figure out exactly where that image is going to be. So what we can do is we can take our image, which is, our object, right, which is right here, and we're going to use lines that are perpendicular. It would be useful if this actually worked. To the mirror and are of equal length on either side of the reflective surface, we can accurately locate the image. It would be useful if this software actually worked. So you can see that that t-shirt image was not entirely my fault up there. All right, so if we have a point right here and we extend all the way to the mirror, right, we can also draw a line of the same length over here, and that'll tell us exactly where that point is. Perpendicular, again, means that we form a right angle right here. And we could do the same thing at another point, right? Those two lines will be equal in length and perpendicular to the mirror, and so on and so forth. So if you don't exactly know what the image is going to look like on the other side, use this method where you're drawing a line perpendicular to the mirror and from the object to the mirror itself, and you will be able to figure it out. So this is what it wants us to do. It wants us to go ahead and take the distance from the object to the mirror and know that is the same as the distance from the image to the mirror. Then we figure out that the imaginary line that connects that object to the image is also perpendicular to the surface of the mirror. So, for example, if I were to say that, I mean, this is really, really easy, this first one right here, right? It's just going to be let's pretend like that's actually a straight line for 1, but we could say it's 5 centimeters. So then we draw another line that's 5 centimeters. Ta-da! Mirror image. But that one's, of course, really easy. This one, okay, we could take this point and not have it shift upward, right? And we know that that's the edge of the G. So we would start swooping down right here and we would curve all the way around. And we'd end up curving backward like that. That wasn't bad. So we know that it's not just going to be G shifted over, because if we measure the distance from this point right here into the mirror, it has to be the same distance as where the image is going to be. So that's why I don't have the G just looking like it normally would, but on the other side of the line. Okay, let's go down to the next one, which is going to be a question mark and a smiley face. Okay. So again, the dot is going to be closest to the mirror. And that means that the tail end of that question mark is going to be right here. And that's when we're going to start going around like that. Of course, it's going to be smaller in size, but you get the point. Smiley face, okay? The smiley face's smile is closest to the mirror, so it's going to be closest to the mirror whenever we reflect it. It's going to be an upside down smiley face, which is exactly how I feel sometimes with y'all in class. Upside down smiley face. Then we've got an A and a W, which these these lines are not exactly perpendicular to the page, so this is going to be a little hard for me. But again, if I just measure from here to here, and then from here to there, again, it has to be perpendicular to the plane. That's a little off. Shouldn't be quite that tilted, but whatever. Well, that's bad. Again, it has to be perpendicular to the mirror, so it's not just going to be flipped over. Lord. All right, so let's continue to what SALT is going to be. This is an acronym that's going to help us characterize the image whenever we're trying to draw it, right? So I'm gonna type in my text this time. So let's go in here. So S, as far as an image goes, S is going to stand for size. Okay, so is the image larger, smaller, or the same size as the object? Okay, and that's going to depend on how far away from the object it is. Okay, now we're going down to A. A is going to stand for the attitude of the image. Okay, more like its orientation in space, okay? So A stands for attitude. So is the image upright or inverted? And inverted just means upside down. Now we'll do another one. We've got L down there, and L stands for location of the image. So where is this image relative to the mirror? And our last letter of the acronym is going to be the type of image. So this is going to be like, can it be projected? Like, for example, on a screen or a piece of paper? If so, then that means it's a real image. If not, it is virtual. And that just means like it looks like it appears inside the mirror. This is the kind of image you see whenever you look at yourself in the mirror. So let's go ahead and draw our diagrams for each of these. So I don't know, I'll do, I guess, a heart. Okay. You could have an image that is larger or an image that is smaller. You could have an image that is upright or an image that is inverted. This one is basically just figuring out, here's my mirror, where it is compared to doesn't like to draw dots. There we go. And then the type of image. So that's going to be my real image. Real versus virtual. So images in our plane mirrors are always going to have the same characteristics. So if you see something in a plane mirror, aka the type of mirror that we use in our homes, it's always going to be the same size as the object. It's always going to be upright. It's always going to be the same distance. Whoopsie. Yikes. As the object is, but it just appears in the mirror. So if you're far away from the mirror, the image in the mirror looks far away from you. And the type of image it is virtual. So here's some practice for you, okay? What I want you to do is I want you to answer these 3 practice questions. You're going to use your own words and describe the difference between a real image and a virtual image. You would use the SALT acronym to describe the image of yourself. Again, remember what happens in a plane mirror that we just discussed. What would happen if you were wearing a t-shirt with your name written across it? What would it look like in the plane mirror? Why emergency vehicles like ambulances often have words painted backwards on their hoods, and why you think that is? And would you ever be able to see your whole body in a plane mirror that is half your height? Explain using your diagram. Okay, so take some moments, pause the video here, answer those questions, and reflect on what we've just done before you move on to the second part here. All right, welcome back. Now we're going to be continuing on with the different types of mirrors. So you can see that I've already filled out these two right here. We've got plane mirrors, which we just went through, and these are the mirrors that are flat. So if I were to draw a diagram of what that looks like, the diagram for a plane mirror looks like this, just a straight up and down line with the, kind of like a little reflective surface there. And I'll just draw a stick figure here since this software does not like to cooperate. Okay. Remember, it's going to be a mirror image, so I'm not going to draw my arm on the left side like I did on the first part of the diagram. It's going to go on the right side. That's called a lateral inversion, by the way. Lateral just means across. So let's keep going with concave and convex. Concave is also known as a converging mirror. Okay, and concave, if you studied your notes last week, looks like the inside of a bowl. And what happens is if you have a light ray coming and striking, like right there, for example, this is going to be ugly, just warning you. Okay, since this surface inside is not completely straight, it's going to bounce off at a certain angle, and that depends on how curvy the surface itself is. But what's going to happen is these rays are basically all going to meet at a certain point. That's why it's called a converging mirror, because they all meet at one point. Let's try that again. You'll know we can draw better than this. This is just the software acting up. Okay, they meet at one point and then diverge again. Okay, so right there. That's where they meet. I probably should have circled that in another color, but you live and you learn. Okay, so now we also have what's called a convex or a diverging type of mirror, and this is the type of mirror that looks like the outside of a bowl or a spoon, and this is one where the light ray hits it and then just decides that it's going to go back in opposite directions. These are not the kind of light rays that are going to come and meet each other for brunch. They have their own things to do. So these rays reflect away from the surface of the mirror. So if we want to think about some applications of these specific types of mirrors, concave mirrors can be used, for example, for makeup application or anytime you want to get real up close to an image. So just type in here. And there's also another application that I think more people are familiar with, but may not know the type of mirror that's actually used. These are also used in headlights and flashlights. This is the reason why the headlight is brighter whenever you're like looking out in front of your car instead of the light that like the bulb itself that actually exists in your headlights. It's because the mirrors on the inside of the headlight piece itself. And convex mirrors, since these diverge, that means that you're able to see a wider swath of image. So that almost looks like it's on a prison. Um, if you've ever been in ISS, we have several of these mirrors across the room so that we're able to see more of what's happening. So these are the types of mirrors that you're also going to see on the sides of your car, right? Your side mirrors. These are convex mirrors because they're able to display a wider image, but the images are going to look smaller. And that's also why they have the warning at the bottom of it that says images in mirror may be closer than they appear. It's exactly why, is because the images look smaller and thus you feel like it's farther away from you when it's really not. Okay. So go ahead and answer on your own. What's the main difference between concave and convex mirrors? Use your diagrams that we just drew to aid in your explanation. Car headlights use converging mirrors or convex mirrors. No, concave, my bad. It's a Sunday. They use concave mirrors. How does this help keep motorists safe? Remember what I just talked about. What type of mirror is used in this parking garage, and how does its characteristics help motorists see around tight corners? So that's going to be your convex mirror this time. So flashlights also use converging mirrors to focus the light. Draw the shape of the light leaving a flashlight if no mirrors are used. A concave mirror is placed behind the light source, or a convex mirror is placed behind the light source. Again, we've got diagrams up here that should be able to aid you with that. And question 5, the satellite dish collects information from satellites in space. Although this is not a mirror, what type of mirror does a satellite dish resemble? And what do you think the piece sticking out in front of the satellite dish does? Okay, reflect on that. Reflect. And question 6, Christmas ornaments called baubles are spherical. If they're polished, they are highly reflective. What type of mirror do these baubles resemble, and how do you know? So that's going to be it for this set of notes over concave and convex mirrors. Through this lesson, you should have learned about exactly which type of mirrors produce which types of images. You also should have seen the difference between all three types of mirrors, whether that's plane, concave, or convex. And you should have seen your salt diagrams. We're going to be doing more salt diagrams in the future, so make sure you reference this in the future if necessary.